All right, welcome everybody. Let's do this. So, lesson 24, multiplying and dividing rational expressions. So, this lesson is not too bad. It's very straightforward. The concepts, let's do it together. Here, the main idea is that if I have some a over b times c over d, it's equal to ac over bd. Basically, it's just saying that if you have, let's say, 2 over 3 times, I don't know, 4 over 5, you're just multiplying 2 times 4 is 8, and 3 times 5 is 15. Okay, and you have 8 over 15. But the same idea applies if I have variables or even polynomials. So let's take a look at this. Here we have x cubed over 4y times y squared over x. So if I just multiply it straight, I get what? I get x cubed y squared and 4xy on the bottom. And you could say, oh, mister, why is it not 4yx? Usually variables are in order according from the alphabet from A to Z. But here, if you just leave your answer like this, it's not enough, because here we always want to simplify. And here, what's the greatest common factor of the numerator and denominator? It is xy. There exists an xy in the bottom and an xy on the top. So here, I could factor the top by xy, and this becomes x squared y. And what's on the bottom, I could factor out an xy from this 4, and I'm left with that 4. And here, the x's cancel and the y's cancel, so I'm just left with x squared y over 4. Okay? And bam, that's it. Let's move on. Here, let me move my book a little bit. Okay, now here, let me camera angle. My bad. Hold up. Nope, that's not good. This. Okay. Here I have 3x minus 6 over 2x plus 6 times 5x plus 15 over 4x plus 8. Now for this problem here, notice that what can I do? I can multiply straight, right? So here, if I have 3x minus 6 over 2x plus 6 times 5x plus 15 over 4x plus 8. Now, if you're thinking, oh, let me FOIL this, you have the right idea. You can just FOIL this. You say, what, like 3x times 5x is 15x, blah, 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 blah. But what you could do is, if possible, so I'll write it here, if possible, factor out GCF. Okay? So here, what's the GCF of 3x minus 6? It'll be 3 times x minus 2. Okay? What about on the bottom here? What's the GCF of 2x plus 6? It's 2 times x plus 3. Here, what's on the top of 5x plus 15? It's 5 times x plus 3. And on the bottom, it's 4 times x plus 2. Okay? Oh god, my bad. The camera angle, hold on, is that better? Yes, that's so much better. I'm sorry about that, guys. Mr. G is messing up on the camera angle. Now here, we could just multiply everything straight. Notice that 3 times 5 is 15, and let's just leave this x minus 2 and x plus 3. And then what's on the bottom? 2 times 4 is 8, and this becomes what? X plus 3 and x plus 2. Okay? Now what can we do? These x plus 3's cancel, and you're just left with 15 times x minus 2 over 8 times x plus 2. And notice that I can't cancel these out because it's a minus 2 and a plus 2. And 15 over 8, can I simplify this fraction 15 over 8? No, you can't. But let's say, for example, there was like 10 over 15, right? If here was 10 over 15, then I would have to simplify it to like 2 over 3, okay? But here you can't simplify 15 over 8 because they don't have, the greatest common factor between the two numbers is 1. Okay, let's turn the page. See, this chapter will be very straightforward. So here it says, summarize what you have learned with your neighbors so far. Okay, forget that one. Here it says, find the following product and reduce it to lowest terms. So the same idea that we had over here with this question down here, that's what I want you to do. Remember, always, 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 if possible, factor out GCF or factor around. Okay? What I want you to do is I want you to try and factor out the GCF or factor around, multiply, and reduce it to lowest terms. Simplify the fraction. Okay? Pause the video and try and do it by yourself. All right? If you want to do it with me here, let's see. If I have 2x plus 6 over x squared plus x minus 6 times x squared minus 4 over 2x, right? Well, let's see. This 2x plus 6, right? This would factor as 2 times x plus 3, okay? This factors as 2 times x plus 3. Sorry, someone's at the door. This x squared minus 4 factors as x plus 2, x minus 2, right? This x squared plus x minus 6 factors as what? X plus 3, x minus 2. And this 2x just becomes 2x, right? Now we need to kind of combine everything together. So I have 2 times x plus 3, x plus 2, x minus 2 is on top. And then what's on the bottom? This x plus 3 is here. This x minus 2 is here. And usually this 2x, you don't want to put it on the bottom right. If it's not like a binomial, you just want to kind of leave it over here. Okay? Now, once we get to this point, this is the favorite part. Isn't this so therapeutic? You just start canceling terms. So we can cancel this, and we can cancel the x minus 2's. Okay? But now, can we cancel the 2's here? Let's see. Let's just rewrite it again real quick. So here, I have 2 times x plus 2 over 2x, right? And here, yes, you can cancel the 2's. I just wanted to show it again just so you don't feel too confused, because 2 divided by 2 is 1, right? So you're just left with x plus 2 over x. And that is a simplified version when you multiply these two rational expressions, right? For this problem here, the textbook is being very extra. I never really showed you. Let's take a look at this. You see, if I just said, hey, multiply and simplify the terms, but there was no negative 2 exponent here, you'd be like, oh, mister, I know exactly how to do this. But textbook is being a little extra, but okay, we could do it. Here, I'm just going to show you the idea. Basically, what happens is this flips, and you have to square everything. So this becomes 3m plus 6 over 4n minus 12, the whole thing squared, times n squared minus 2n minus 3 over m squared plus 4m plus 4. Okay? For this one, let's do this problem together as a class, okay? If you want, you could try and do it by yourself, but if you want to skip it just to move on, that's fine too. Let's move on to the next part. Here, what are we going to do with this? This is a new idea. This says find the quotient. So we're not multiplying, we're dividing, okay? And let's just try and remember, if I have two fractions, for example, if I have 2 over 3 times 4 over 5, if I have multiplication, what do? I just do 2 times 4 is 8, and 3 times 5 is 15, and then you just say, you know, happy face. But if I say 2 over 3 divided by 4 over 5, we have to do our keep, change, flip. So this keep the 2/3. You change this to multiplication. Oh, sorry. You keep the 2/3. You change the division to multiplication, and you're going to flip the 4 and the 5. So this becomes 5 over 4. So this just becomes 2 times 5 is 10 over 12, and you reduce this fraction to 5 over 6, right? And that's the same idea with rational expressions, that you keep this, change this, and you're going to flip that. So here, this becomes x squared minus 4 over 3x. This division changes to multiplication, and this becomes 2x over x minus 2. You're just going to flip these two. And then you're just going to play the same game of multiplying these two expressions and then simplifying it like we did over here. Okay? The rest of the chapter, you can do this by yourself. This one is pretty straightforward. This one you could do. This one, don't freak out too much. basically for this question here, the way you're doing it, you're doing x plus 2 over x squared minus 2x minus 3 divided by x squared minus x minus 6 over x squared plus 6x plus 5, right? Here, just take a second and pause and see what I wrote. You're literally just taking this divided by that. They just show it in a different representation. But what are you going to do? You keep, change, and then you flip. And then you multiply and simplify and all that stuff. And then here are extra practice problems we'll do. I hope this video was good. I thought it was pretty smooth just by listening to myself. Okay, I'll see you in class.